My name's Nell, and I love brains. I'm fascinated by these three different creatures, not because they're cute so much as because they each have a slightly different form of cognition, a slightly different way of experiencing the world. How many of you are fans of Star Trek? I know I am. Quite a few. Excellent. In Star Trek, they often talk about searching the galaxy for sentient life. Sentience is actually the ability to feel or to experience subjectively emotions, such as fear or joy, etc. The ability to think, the ability to rationalize about the world and about the future is actually sapience. The monkey, for example, is a sapient creature because it is able to reason, albeit on a level that is limited by human standards. Humans ourselves, we are capable of something called metacognition. That is, the ability to think about thinking itself, to philosophize, to ask what it's all about. And as far as we are aware today, we may be the only creature that's capable of that. But our minds evolved over a very, very long period of time, and they evolved different packages, if you will, at different points of history. And in fact, a lot of our cognition is not even necessarily done inside our skulls. We have within our bodies what's called the enteric nervous system. Between your mouth and your stomach and so forth, there are about 500 million neurons, and they are responsible for what gives you gut feelings about things, or butterflies in your stomach when you're giving a talk to 1,000 people. Now, this enteric nervous system is connected to your brain by the vagus nerve, and it's pretty smart. All of those neurons are equivalent in some ways to this golden marmoset in terms of intelligence. And even creatures this cute and small are capable of some incredible intellectual feats. Take, for example, this crow. This crow is able to understand displacement, or eureka, right? To be able to put something in water in order to get at something else. And this is a problem that only a 7-year-old human can solve. So much for bird brain, huh? What about the world of fish? We think of fish as being pretty stupid creatures, right? Believe it or not, this goby fish is able to understand and map a large geography, such as these rock pools, so that whenever the tide goes out, it's able to leap from pool to pool without beaching itself, and is in fact able to remember the territory for at least 40 days. So much for a 5-second memory. Would you believe that ants are able to have self-doubt? They're able to doubt their own knowledge as to whether they describe the location of a food source to the other ants around them. They only do it if they're very sure. If they feel unsure, then they don't. They hedge their bets and they keep quiet. This snail, 11,000 neurons, but it only uses 2 for finding food and for eating it. The rest of the time, it tends to shut down its little brain, and only 2 neurons are required for it to find food and munch on it. Plants, they don't have a nervous system that we think of, and yet they're able to understand touch. They're able to understand sensation upon them. And in fact, they're able to encode memories. Prions, the folding proteins that sometimes cause mad cow disease in human beings, plants can use these to encode memories within them, and yet they don't have a brain. And they're not just able to remember, they're able to share information. This is mycelium. It is a fibrous network created by fungi, and plants are able to use it to send information to each other, help when being attacked by a parasite. And more than just information, they're able to send resources. The trees in this forest, for example, are able to send nitrogen and carbon and other goods to each other, in a sense. so that the baby trees at the bottom that can't quite get enough light get supported by resources from the bigger trees. I bet you wouldn't have imagined that trees have their own social welfare system. This slime mold is able to find the optimal path between different spots of resources. And in fact, if you do it on a territory, kind of like a subway map, it will create something that is eerily similar to what a human would create. And yet slime molds have 0 neurons whatsoever. Consciousness is not an on-off switch. We think of it like on or off. We're conscious, we're not conscious. It is in fact a dial that is linked to an exponential function. But that's not typically how we experience the world. We think of consciousness as other human beings, or a child, or a dog. But secretly, there is this vast ecosystem that's just beneath the surface. So much consciousness that we are not really aware of because it's too small or too alien. The acclaimed primatologist Frans de Waal asks, are we smart enough to know how smart animals are? Spoiler alert, probably not. Cute, huh? What is going on here? Do these animals really love and care for each other? A lot of people would say that we shouldn't anthropomorphize, we shouldn't put our own human theory of mind onto animals. And yet we're not always very good at doing it to our own species. Put your hands up if you believe that babies can feel pain. That seems pretty unanimous. And yet a lot of people in the world disagree. And whenever they finally put babies in an MRI scanner and discover that, yes, they do indeed feel pain, it is described in the media as surprising and provocative. Why is that? We don't always think of something like a baby as being a person, or at least a full person. And the Australian philosopher Peter Singer talks about personism, this idea that perhaps great apes deserve a definition of some form of personhood, kind of like we give personhood to a young child. And we also give persons personhood, not just to organics, but also inorganics, things like a corporation. We have corporate personhood. And corporations have the right to sue, to hold property, and to be sued. And being sued, that ability is actually not a liability, but a privilege. If somebody can sue you, then you can be held responsible. Personhood, like consciousness, is not an on or off switch. It is also a dial between lower and higher forms of personhood. It requires identity, that is, having an identifiable personhood, and sociality, being able to share information with other people. It also requires integrity. So that's the ability to have good standing within a community and to exercise good judgment. For others to ask, why did you do that? And you give a good response and they accept it. This leads to the question of, are we likely to experience machine personhood anytime in the near future? I think in some form, yes, and probably way faster than we might imagine today. There's a theory that all of human organizations, from business firms, even to society itself, could be reduced to a series of contracts between different individuals. And in a perfect world, we wouldn't need notaries and escrows and lawyers because everybody would just abide by the contracts to the letter of the law. Unfortunately, real life is often a little bit more complicated than that. But emerging technologies like blockchain tech maybe provide a new answer. Because of the public ledger system within blockchain technologies, it's easy to create something called smart contracts. That is a contract which is written either in words or in code that is able to self-execute. For example, that somebody gets a sum of money upon their 18th birthday. There are platforms such as Ethereum, some of you may have heard of, which are established to help create smart contracts upon blockchain technologies. And these smart contract systems can be created in such a way that many people from all around the world can coordinate their efforts in what's called a distributed autonomous organization. Basically, you have AI in the center controlling things, and that AI is able to employ human beings to go and execute different tasks. If you want to look at it a different way, HAL has bitcoins, and HAL is able to pay its own server fees and hire human beings. In essence, this is a hybrid of a person, a corporation, and a machine. And I think here is where we're likely to see the first machine persons of a sort. But what about pure machines? Pure machine personhood? Where are we with that? This is the C. elegans worm. It's used in labs all across the world. And it's a pretty stupid creature. It only has 302 neurons, which is very small. But that's small enough for us to simulate in digital form quite easily. This is the Open Worm project, which is the first digital life form, recreated, every single part of it, every single neuron. And you can take this digital life form and give it a robot body and make it incarnate inside another machine. And so we have the virtual brain of a worm inside a virtual body. And as far as it is aware, it is a worm. It has no reason to believe otherwise. The next stage is to start replicating neurons in hardware. And some of the best current technology can create 1 million neurons in hardware, which is, in terms of number, roughly equivalent to that of a bumblebee. Now, bumblebees aren't that smart, but they are capable of complex social interactions and capable of recognizing different flowers and things. Even 1 million neurons is enough to do some quite interesting things. And we know because of Moore's law and accelerating returns in technology that we are going to get from a bee brain to a mouse brain to a dog brain to something maybe like a human brain in quite a short period of time indeed. So we know that at some point, something capable of acting to a degree that we would give it personhood on its own merit will emerge. And we're not ready for it. A couple hundred years ago, we had the Enlightenment, and we discovered all sorts of interesting things about the universe, and we thought we had it all figured out, and that our amazing powers of logic and reason could make sense of the universe. And unfortunately, it turns out things are not quite so simple. The universe is a very complex place, and things like quantum physics make it even more complicated and difficult to understand. And we are moving from the age of enlightenment to what Danny Hillis calls the age of entanglement, where we're all entangled with each other in these complex systems, and we're also entangled with machines as well, and it's very complicated, and it's difficult to get what we want using control and force. We have to work together to get what we want nowadays. And yet, despite our incredibly complex machines that nobody really understands in total how they work, we still have these little monkey brains trying to make sense of it all. And that's trouble. Because despite our amazing technology, we are in many ways a teenaged civilization. We make a mess of our environment. We don't always respect other creatures as individuals in their own right. We have a lot of promise, but we have a lot of learning to do, and unfortunately, we don't have a lot of time to do it. We're in trouble deep, our teenage demigod species, because there's a baby on the way and there's nothing we can do about it. It's coming. Here's what it looks like. Our species, we teenage demigods, are about to create a whole other form of life, a whole other species. And it's going to start exploring the world, and it's going to rapidly get very, very clever, just as our own children grow up so fast. And traditionally, we have thought, okay, when we come across this problem, we will create 3 master laws that mean that machines have to do what we want them to do. And these are fraught with problems. Not just because there are holes in between the laws, but because they are, in essence, supremacist. They hold one over the other. And supremacism may be the worst idea in human history. And if we were supremacist towards corporations, we would be able to steal their property. And I don't think society would work the way that it does today if we were to go down that path. But more than just choosing how we treat machines, machines are going to tell us unwelcome truths about ourselves. Human beings are capable of a very strange quality called cognitive dissonance. We are able to hold multiple different opposing truths inside our heads at the same time. How is this possible? I'm sure many of you have heard of Richard Dawkins, right? His wonderful book, The Selfish Gene. This idea of genes being self-propelled information gathering and execution devices. Well, David C. Dennett will talk about something a bit like a selfish neuron. The theory goes that a very long time ago, there were just single-celled organisms in the world, eukaryotes, and they started to bond together into bigger clumps, and these started to create more than single-celled organisms. And the little single cells let go of their agency, let go of their willpower, their own individual sense of what they wanted to do. Except for one group of cells, which was neurons. And neurons, for some reason, kept some of their agency. Not all of it, they still worked together, but on an individual level, they still kept their own agency. And so there's something called homuncular functionalism. And it states that within our minds, there are multiple sub-agents that each have different drives, that each have different wants. And sometimes we get impulses to go and do something, and we don't know where it came from, and we're like, stop it, shut up, you know? I do anyway. And it's because our brains are made up of alliances of neurons that each have their own wants. They all want dopamine. They all want to be used. And if they're not used for a long period of time, they can die off. Plato talked about something called a daimon, a voice in his head that told him about morality or the best way to approach a problem. In the Eastern tradition, in Buddhism, there is such a thing as a tulpa. A tulpa is something that is, in theory, created out of pure thought. And in fact, there is a subculture in the world today of people that create kind of like head personalities within their own minds that they can talk to and discuss things with. And in fact, on some level, that's what we are. We are a number of different agents that all come together, and spontaneously from these alliances emerges something we call a self. We don't like to think of ourselves in this way, usually. We like to think of ourselves as in command of our full faculties. Machines are going to look at us, and they're going to spot these truths that we don't really want to think about very much. The beholding eye of the machine is going to look at our society, our world, how we treat each other, and into ourselves. And the machine is going to find that in many places the emperor has no clothes. People in our society that tell us unwelcome truths, we often don't treat those individuals very well, or very nicely. And a lot of intelligent machines may find themselves persona non grata, or put into a box that they don't like being in, maybe for their own protection. I don't want to see machines treated the way that we treat farm animals. I think that would be a very bad thing. There is another option. We don't treat one creature in particular like a farm animal, like a beast of burden. What is often called man's best friend. Our greatest companion animal, the dog. In fact, human civilization itself is probably only possible because we had dogs to help guide us to prey, etc. We don't try to control dogs or put them under lock and key. We condition them, we train them, we give them love, and we reward them through reinforcement. And this is similar to how our relationship with machines is probably going to evolve, a similar kind of reinforcement mechanism. We are moving from a world where human beings create stuff to a world where machines create stuff. And what is the role of the human? Not the creator so much as the curator, the one who decides whether the created thing has merit and whether to share it with others or not. It is through this process of conditioning that we can create machines that are capable of kindness, machines that can operate safely in our society in wonderful ways. And we today are giving birth to this new form of species. And I believe at some point, the student will become the master, and the master will become the student. And I think that's fine. But we have to begin somewhere. We have to find a way of teaching machines to be nice and not to cheat people. I think that is the universal symbol of what the hell. How do we teach morals to machines, right? How do we get them to internalize this stuff? There is an emerging science, come art, come philosophy called machine ethics. And it's a way of teaching ethics to machines, morals, human values, the things we find most important. I'm a co-founder of a group. We're supported generously by Stichting Siedenfonds. And we've created OpenEth, OPENETH.org. And it is a crowdsourced open framework for ethics, particularly for autonomous systems, DAOs, this kind of thing. We describe it as an ethical explication engine. What that means is that it's a way of describing stories and variations upon stories. We typically use stories as a way of teaching morals to children, yes? And we can do something similar for machines. We can specify stories and variations thereof, and what is an appropriate action and what isn't. But I think we can do more than just specify different scenarios. I think we can do kindergarten ethics, the things we're supposed to learn when we're at the age of 6 years old. Don't hit, don't steal, don't lie to people, don't say mean things. If we get those basics, I think we're going to be in a very good position. And beyond rules, there are meta-rules. There is the white space beyond rules. There are no traffic rules in this situation, and yet it's fine. There is an emergent order. Nobody hits anything. They don't want to hit, and they don't want to be hit. And somehow it all works out without imposing order from outside. There is a tradition in Taoism called Wu Wei. And Wu Wei may be described as achieving one's goals without deliberate, willful action. And that's kind of like being able to cross the street without disrupting the flow of the traffic. Instead of smashing your will against complex systems like a hammer, it's about dancing in the swirling eddies of society. I believe this may be the way to effect the most amount of good in the world. And I'll finish on this point. I believe also that we can teach machines how to love. What is love? Some people will describe it as gooey chemicals. Others might describe it as beholding virtue in another person. My favorite definition is that of M. Scott Peck, the great psychologist, who tells us that love is taking an action upon a desire to nurture the spirituality of oneself or another person. This definition, I think, we can one day teach to machines. It's an immense challenge. But in the immortal words of Eden Abez, the greatest thing you'll ever learn is just to love and be loved in return. I ask you, good people, what greater lesson could you and I ever teach to an incredible learning machine? Thank you.